Okay, welcome back. This is a calculus tutorial. Again, part 3 of integration by parts. And I just figured I'd work out this example right here to just show it's not too complicated. It looks a little bit tough. It's just sitting there, but it's actually really quite simple. So I'm going to run through the steps to solve that one. And then I'm going to show you some other stuff when you're dealing with some simple trigonometric functions as well. So let me just clear this off, and we'll start by writing it again. So if I have the integral of t to the times sine 4t dt. Okay, if we start there, again, remember we have to choose which one of these is going to be f of x and which one of them is going to be g of x, or g of t. So with that, I'm going to select, because this t is sitting out there, I know the original formula for solving integration by parts is f of x g prime of x dx equals f of x g of x minus the integral, and that is f prime of x, and then gx dx. So that's where what we're going to be using to solve this. So if you look at it, if I select f of x or f of t as just t, then I get to get rid of it right here, because the integral, or the derivative of that, is just going to be 1. So it's very tempting, and what you'll find out is you can force your way through it. It would work the other way if you selected badly. You might be able to recognize that you selected badly pretty early on and then be able to reverse it and go back. It's kind of feeling your way through it a little bit at first. So let's go with f of t equals to t. F prime of t would then be equal to 1 dt. And then I'm selecting g prime of t. I'm going to probably write in x a few times because I'm just by habit. I'm going to try not to do that. But that's going to be equal, I'm going to set it equal to sine 4t dt. Okay, and then I have to know what the integral of that is, and luckily it's a simple trigonometric function, so it's not going to be hard. So I'm going to actually get, let's see, the integral of sine x is negative cosine x. So then I also have to do the integral to dx of that part right there. And so that is why I get to 1/4, negative 1/4 cosine 4t right there. I hope that makes sense to you. I just, if you take the derivative of this one, you will get to here, because you'll reverse the sign, because you'll get a negative sign. That'll get rid of that negative, and then you take the derivative of the 4t on the inside, which puts a 4 on the outside, which is canceled out by the 1/4 there. So everything is set up, works pretty well. So let's go on with inserting this into our equation. So sine 4t dt, and that's going to equal, I'm going right up here, f of x and g of x, or f of t and g of t. So I'm going to have t times negative 1/4 cosine 4t, and that ends that, minus, and then the integral of this derivative right here. So I have 1. I'm going to put the dt out here, and then I need to multiply that by this one right here, which is a negative 1/4 cosine 4t. There, that's why I left the space to put that in there, and the dt is at the end. So next step is I'm going to just move my constants out of the integral so that negative and negative becomes a positive. The 1 goes away, and I just have 1/4. And then I just take the integral of cosine 4t dt. Okay, and then I have this part over here. I'm just going to rearrange it to make it a little bit neater. And I have the negative 1/4 t here, and then cosine 4t there. Okay, I won't bother writing that other part there. Okay, so next step is I need to evaluate what is that integral, and that's relatively simple because that would just give me another sine 4t to the 1/4 there. And so that's what I'm going to have right here. 1/4 sine 4t. I'll just knock it off of here. 1/4. And then I'm going to have equals negative 1/4 t cosine 4t. There. So just distribute that. I have 1/8 sine 4t there, negative 1/4 t cosine 4t, and there's a plus sign there. And then, of course, since I didn't do a definite integral, this is plus a constant here, so that is going to be my answer for that one. So pretty straightforward, just takes a little bit of bookkeeping working through that. But real quick, I want to show you an interesting phenomenon that happens if I say it wasn't a t in the front, say it was something like the integral of e to the x cosine x dx. Now, the one textbook I was looking at has this as an example, except with a sign in there. But I'm going to just run it with a cosine to be a little bit different. I'm going to run it a little bit backwards from the way the textbook runs it, just so you can see how it works out both ways, and also you'll see the phenomenon that I'll point out in just a second. So I'm going to select f of x equals cosine x, and therefore my f prime of x is going to be equal to negative sine x, and then my g prime of x is going to be equal to e to the x. G to the x equals e to the x. Okay, so then we'll just start working through. And so x cosine x dx equals those two minus the integral, and that's going to be a minus sine x e x dx. I should follow my own notation here. There. Okay, so that becomes a positive and a positive, and now we look at this and we have kind of the same thing. We have to do another integration by parts here. So sine or e to the x sine x dx equals, and I'm going to select my f of x. In this case is going to be sine x f prime will be cosine x, and g of x will just be, and then g prime of x will just equal to ex as well. So with that, I'm going to have ex sine x minus the integral ex cosine x dx. This is dx, dx. Okay, so I'm going to insert that in for here. So e to the x cosine x dx equals e to the x cosine x plus what I just found out right here. So that is e to the x sine x minus e to the x cosine x dx. And what you'll notice is I'm exactly back where we started. And so the great thing is the sign on this is negative, sign on this side equal sign's positive. So if I plus this side by e to the x cosine x dx, and then do a plus e to the x cosine x dx, I'm going to get 2 e to the x cosine x dx equals e to the x cosine x plus e to the x sine x, and I can divide both sides by 2 and get my answer for the original integral. So that's something to watch out for. If you see that happening, you see a repeating cycle, and you got the opposite sign on either sides of the equal sign, you're there. So you've got it. So you just have the answer right like that. So anyway, hope this helps. Again, it's a little bit of practice. Definitely take some time, go through the textbook examples and, of course, your homework examples. And try to think about it as you go along. Subscribe to my channel. There'll be more parts. Part 4 is coming soon to try to get you understanding all these little tricks in there that your professor probably doesn't have time to show you in class. Or he's moving along or she's moving along too quickly for you to really understand. So anyway, good luck. Subscribe to my channel. Hope you like it. Good luck.